Hello and welcome to another calculus tutorial, which is today going to focus on how to find the equation of the tangent line at a particular point. Now you can see the function that we've got in front of us here is quite a complicated looking one if we're going to be differentiating eventually, because we will be differentiating it because if we realise that we're going to have to find the equation of this tangent line, and in the equation of the tangent line, in the form y equals mx plus c, we have a gradient, okay? So we're going to have to find that as well as the y-intercept. And the y-intercept is going to be found knowing the point of tangency. Now we know that x equals 5 is the x-coordinate at the point of tangency, where the tangent hits that curve, that function. Okay, so we don't know what the y-coordinate is yet. Okay, so we need to go and find what that is. And the way that we would do that is to realize that f of x is another way of saying y, and to say that if x is equal to 5, then the y coordinate would be 2 times 5 minus 1. Let's just tidy that up slightly. 2 times 5 minus 1. Probably worked out already. Which is the square root of 9, which is 3. Okay, so the point we're looking at is actually 5, 3. Okay, so you imagine this curve, and it's at 5, 3, we've got a tangent, and it's our job to find what the equation of that tangent is. The way that we do that is that we're going to have to find the gradient function. Okay, so the gradient function, f dashed x, is going to be found via the chain rule, because what we've got here is a function within a function. The function within the function is 2x minus 1. And then if we rewrite the overall function, y equals, in terms of u, what we've got is square root of u, which is u to the power of a half. Now, if we then go and differentiate those things, first of all, u with respect to x, and secondly, y with respect to u, we're on our way to solving by the chain rule, because the chain rule says that dy by dx is equal to du by dx times by dy by du. Okay, so let's go and find those things. This one's really easy. If we differentiate 2x minus 1, we get 2. If we differentiate this one, we're going to need this form. So coefficient times power is 1 times a half. And then take 1 away from a half is minus 1 half. Okay, so by the chain rule now, all I need to do is to multiply those two things together. And I'm going to get, to put those two things together, dy by dx equals 2 times a half, which is 1. U is actually 2x minus 1, and it's to the power of a half. I could also write that as 1 over the square root of 2x minus 1. If you're really good with your laws of indices, you'll be having no problem there. Okay, so we're not there yet, because now we need to think, if this is the gradient function, okay, I now have what I need to find the gradient, the value of the gradient of the tangent line, by finding the gradient at the point x equals 5. If I just put x equals 5 into that gradient function, what I get is 1 over square root of 2 times 5 minus 1, which is 1 over the square root of 9, which is 1 over 3. So the gradient is actually 3. M is 3, which is this here. Sorry, 3, what am I saying? A third. Yeah, okay. So let's keep going. So nearly there. Y equals a third x plus c. And I also found at the beginning what the actual point of tangency was. It's 5, 3. So we know that 5, 3 is the point we're looking at. So when x equals 5, y equals 3. Let's put those values in now. So we've got 3 equals a third times 5 plus c. 3 equals 5 over 3 plus c, I think. So 3 equals 5 over 3 plus c. C is 3 subtract 5 over 3, which is equal to, what would it be? 4 over 3. Yeah, 4 over 3. And so we could just leave it like that. It's not asked us to give it in sort of integer form or anything like that. So what we've got then, y equals a third x plus 4 over 3 is my final answer. Whoopsie daisy. Okay. All right. Okay. Let's Just fix that. Okay, good. All right, so you can just about see that at the end. Let's go and have a look at the second question. So this one, suppose f of x equals, I've learnt my lesson. I'm going to take this up here a little bit. Okay, f of x is e to the power 2x. Find the equation of the tangent line again, x equals -1. This time, now, in a previous tutorial, I learnt this rule that if we've got e to the kx, then dy by dx equals ke to the kx. That is going to save me some room on this page, isn't it? Yeah, because I straight away know that the gradient function would be 2e to the 2x. Great, that's perfect. Cut some corners there. And I also want to find the full sort of coordinates of my point of tangency. So I know the x-coordinate's -1. If I put -1 in here, I'd get e to the -2. And that's not very clear, is it? Let's make that clear. So I've got -1, and then e to the power 2 times -1, which is -2. So I've got, that's my point of tangency. That's where the tangent hits the curve. Point of, tangency. Is that okay? Yeah. Tangency. Okay. So next job is to actually find the m value in my equation of the tangent. I've got plenty of room now to play with. X equals -1. So if I put that into the gradient function, -1, I'm going to get 2e to the 2 to the -1, which equals 2e to the -2. Right, so I can go and put that in now, and I've got y equals 2e to the -2x plus c. Almost there. Okay, I'm building things into it. Okay, so this is my m. And then I just need to go and substitute in the values from up here into my equation. So I've got -1 and e to the -2 to put in. E to the -2 is equal to 2e to the -2 times -1 plus c. Let's simplify that. E to the -2 is -2 e to the -2 plus c. Now I've got e to the -2 twice, so if I actually move -2 e to the -2, if I add 2 e to the -2 to both sides, basically, I'm going to get 3 e to the -2 as my value of c. So my final answer, I've got everything together now. Have a nice green. So what I've got then is got that piece of information as well now. So I can say y equals 2e to the -2x plus 3e to the -2. That's nice. Yeah. Okay, sorry about the equal sign there. Okay, so it's the same process as I've been used to. The only thing is now we're working with exponential functions, but it's still the same. Don't be daunted by that. Okay, it works the same way. Just use your rules such as this. You're okay. Last one, we're going to look at a normal line now. Again, I'm going to make myself a bit more room, just in case. Suppose f of x equals ln brackets x squared minus 1. Find the normal line to the function where x equals 4. Now, the normal line we know is perpendicular to the tangent line. So if the tangent line has a gradient of m, okay, the normal line gradient is the negative reciprocal of that, which is -1/m. That's something to bear in mind. I'd also like to find the point of tangency here. So if I put 4 into this function here, I'm going to get ln 4 squared minus 1. 4 squared is 16 to ln 15. Okay, ln 15, all right. And I've got this. And again, a normal line is a straight line. So it's going to be in the form y equals mx plus c eventually. But I've got to go and investigate what this function's gradient function is. Okay, now, when I was looking at derivatives of e to the x and ln x in a previous tutorial, I came up with this general result, which is if you've got f of x equals ln, let's make a bit more room, cut myself off there. If you've got anything, okay, my room, and then I'll fence it off afterwards. Okay, so if you've got ln f of x, okay, then f dashed x is actually equal to f dashed x over f of x. Just realised I've just duplicated f of x. It's not very clever, is it? Let's go back. Sorry. I'm going to just change that into y. Okay. So that would be very confusing. Oh dear. Right. Okay, so y there, and then we've got dy by dx. Yeah. Okay, so yeah. Okay, so this is going to come in handy. We got there eventually. Let's just put that. Let's fence it off now. Oh dear. Sorry, guys. This is taking longer than it should. Okay. So given that rule down there that we know, f dashed x here. If we differentiate the top here, we get 2x. And then on the bottom, we've got the function itself, x squared minus 1. Okay, so that's saved some time, hasn't it? Just knowing that. That's really nice and quick and easy. And then I know that x equals 4, right? So the point of tangency is 4 ln 15. All right, so x equals 4 goes in here. This is going to give us the gradient of the tangent. It's going to be f dashed 4 going in. So it's going to be 2 times 4 over 4 squared minus 1, which is going to be 8 over 15. Okay. Now, if the gradient of the tangent is 8 over 15, it means that the gradient of the normal will be the negative reciprocal of that. So it will be negative 1 over 8 over 15, which will be negative 15 over 8. Yep. Okay, so we have got this value of m now. The gradient of the normal is minus 15 over 8. So let's start to put that in. We've got y equals minus 15 over 8 x plus c. Okay, now the last thing to find is the c, and this is what we're going to use to find that. Okay, so the point of tangency, this is the point where it hits. Okay, so we know that these values fit this normal line function. Okay, so let's put the values in. What we get is ln 15 is minus 15 over 8 times 4 plus c. Okay, so ln 15, c is going to be equal to ln 15 plus 60 over 8. It's a bit random, isn't it? Okay. I feel like I'm going to have to go over the next page just to do the final answer for this. So, yeah. Okay, so the final answer for the equation of the normal here is y equals, what was it? Minus 15 over 8 x plus, and then I might just put this in brackets just because it is a bit random, ln 15 plus 60 over 8. And I'm just going to leave it like that because that is the answer. And, you know, that's the equation of the normal line at that point. Okay, as weird as it is. We've got the gradient, we've got the y-intercept. Okay, that's what it is. It is what it is. Okay, so there's 3 questions there. What's in it? Okay, chain rules in there, differentiating exponential functions and logarithmic functions, and equations of tangents and normals is in there as well. So I hope that's been clear enough and that you enjoyed it. And hopefully you'll be ready and set to get on with some questions based on this topic now. Okay, so good luck.